Electrical safety is highly dependent on equipment maintenance. Equipment that isn't maintained is much more likely to malfunction during operation. So open up those control panels, give a checkup, and catch potential issues like debris, missing covers and guards, loose linkages, and other potential problems.
Take breakers and switches as an example. Some have been in the closed position for years, and that puts us at greater risk of an arc flash event when we open them. Breaker trip settings also play a major role in arc flash study calculations. If your breakers aren't tested and operating to the correct specs, it will affect your calculations, and that could cause a serious problem for someone working downstream who might be underprepared for an arcing event.
How is electrical safety influenced by equipment maintenance? Think of proper equipment maintenance as an inherent method in the hierarchy of risk control. This might seem strange, but figure that equipment maintenance leads to better performance. And that cuts down on troubleshooting and inadvertent shutdowns. Troubleshooting is a very dangerous task for a lot of reasons. Equipment in this environment is generally time sensitive, which can cause maintenance staff to rush. Troubleshooting is performed energized. Troubleshooting is performed in close proximity to equipment. Equipment interaction is high during troubleshooting. And the fact that we're troubleshooting implies that there is something wrong somewhere. This increases the likelihood of an event occurring. It is unlikely we'll ever completely eliminate troubleshooting, but by performing equipment maintenance, we can lessen the need and improve added risks.
Why schedule maintenance if everything is running properly? It takes time, and that costs money. But think about this. Electrical maintenance can be planned and budgeted for. Repairs will almost always catch you off guard, and you'll be paying for them with downtime and decreased productivity. There's an old promise with electrical maintenance. If you don't schedule it, it will schedule itself. And it probably won't check your production calendar before it does. And look, if you're into fine wine, electrical infrastructure does not get better with age.
When it comes to equipment maintenance, there are different levels of cleaning and testing. Most facilities briefly shut down once a year to perform general cleaning and inspection of switchgear and panels. This is a great practice that should be implemented in your facility if you haven't already. This usually includes wiping down surfaces with a rag, vacuuming debris from inside the gear, operating switches and breakers, and making a quick inspection to spot obvious issues. Follow the manufacturer's recommendations for correct process and approving cleaning solvents. Equipment maintenance is an obvious scenario where an electrically safe work condition should be created. And even better, you can use it as a learning opportunity. Get your team together to demonstrate their practices for creating an electrically safe work condition. It's a great way to reinforce the process of creating an electrically safe work condition and wearing PPE.
Predictive maintenance techniques take a more in-depth strategy. Predictive maintenance determines the condition of electrical assets that are in service to estimate when maintenance should be performed. Typically, predictive maintenance is faster and less costly than time-based preventative maintenance and run-to-failure reactive maintenance. The main preventative maintenance techniques used on electrical systems are infrared inspections, ultrasound inspections, motor testing, including motor circuit analysis and electrical signature analysis, vibration analysis, and fluid analysis. In most cases, facilities turn to a qualified vendor to assist with these services.
Non-destructive style testing, inspection, and maintenance is an advanced type of maintenance and usually occurs in a 2 to 3 year cycle. There are 3 types of tests performed: installation resistance, current path resistance, and equipment functionality. Some examples of these tests are primary injection testing on breakers to simulate a fault and record response time, turn ratio and power factor testing on transformers, high potential testing of cables, Megger installation testing of switchgear, pickup settings on relays. Examples of inspections performed during this process are gap testing for breaker, trip actuator adjustments, time dial changes, spring tension adjustments.
Only qualified individuals are allowed to perform maintenance on equipment. For advanced levels of predictive and preventative maintenance, testing personnel should meet specific certifications. We'll go into more detail shortly. First, let's discuss how to execute the proper equipment maintenance for your facility. We won't dive into the specifics of your equipment. Instead, our goal is to help you understand how to create a maintenance program for yourself and give you the tools to find the standards for equipment maintenance. Predictive and preventative maintenance are highly technical and require expensive equipment. For most facilities, it's more cost-effective to use an outside contractor than to purchase the equipment.
So, how do you look for help? If you purchased the Maintenance Manager Bundle, you should have received a copy of the NFPA 70B. If not, go to the nfpa.org. This manual is well organized and centered around equipment maintenance. It details different equipment and testing topics presented in a way qualified individuals will understand. Other publications can reference are IEEE bulk books, NETA, NIOSH, and OEM standards. Manufacturer manuals specific to equipment are also imperative while performing equipment maintenance. For this training, we primarily reference the NFPA 70B to outline this process.
To begin, identify what equipment you should work on, then determine how to get the maintenance performed. When identifying equipment, start with what is most important. You can use the list of critical safety equipment your team came up with during the previous section. Ask yourself if there are other areas where your team is consistently interacting with an electrical hazard. As soon as you start a maintenance program, you should develop a system for tracking results. Most reputable testing firms will have a system in place, but you should also store everything internally in case you decide to switch vendors or need the information for another project. If this is your first time performing maintenance on a piece of equipment, establish a baseline. Proving equipment maintenance ROI to upper management is much easier when you have as found, as left test results and can explain how ignoring the issues would have caused a catastrophic event. You could also justify maintenance by showing improved uptime in facilities. With this in mind, use data from critical equipment that has had the most issues over the past 3 to 5 years.
Next, look at the equipment's age. Nearly every facility has some vintage gear. We're talking about equipment that was installed when the facility was built and was never used or isn't clearly visible. When you schedule maintenance for this equipment, take extra precautions. It might be decades since protective devices were operated, and failure is more likely to occur. Always have a backup plan. In rare instances, this equipment may not be in good enough condition to be re-energized. Plan in advance for this possibility, and remember, most reputable testing agencies will help with spare equipment and retrofit plans.
Once you identify the equipment to perform maintenance on in your facility, it's time to come up with a plan. Cleaning, inspecting, and thermal scanning are done every year at minimum. More invasive preventative maintenance is performed on a 2 to 3 year cycle. Facilities with a lot of airborne debris or messy environments should perform maintenance more frequently. Refer to the equipment manufacturer's recommendations for maintenance intervals when available. Keep in mind that when performing maintenance, you may be subjecting you or your team to hazardous materials such as asbestos, PCBs, lead, and other harmful agents.
The maintenance manager, or engineering group at a facility, is generally responsible for the maintenance program. The responsible party should have the technical skills needed to understand the work being performed on the equipment and the leadership capabilities to execute projects and get budgets approved.
That's our section on equipment maintenance. Remember, the better you maintain equipment at your facility, the better you'll be ready for that one moment there's a risk and you need everything to go right.
Unmaintained equipment will lead to more troubleshooting, forcing your team to interact with potential hazard more frequently. Plus, malfunction increases the likelihood of an injury or fatality. With proper maintenance, you can control that one moment. Please complete the form on this page of your handbook to begin your maintenance program.